Hello, and welcome to today's engineering discussion from Highwater Studio. Last week, we looked at how to model a manometer in Roblox, over there. This week, we're going to be looking at how to model stream flow and how to model specifically mixed stream concentrations when you have stream flow, a stream concentration mixing with some kind of an outfall from maybe like a wastewater treatment plant or industrial applications. And so, kind of a sneak preview, spoiler alert here of what we're going to be doing the finished product. Oh, actually, I got to jump into it. We have, modeled this. There we go. Where we're going to use screen GUIs and connect local events to server events. So that's another one of the things we're going to be talking about in more of a programming Roblox type of discussion here. But let's see, can I zoom in just a little bit? So we're able to control pipe flow and pipe concentrations using these GUI events. And these connect to server events by firing remote events. So we're able to look at what different flows and concentration combinations with our mixed stream, what our total flow and total concentration would be. So that's what we're going to do today, and let's go ahead and get right into it. Okay, welcome back. And so what we're going to do now is jump into the explanation of how we built this and how we're going to code it. And the only coding we're going to do live today is in our stream script. So we have no stream script. That's going to be definitely, the lion's share of the work that's going to be going on. That's really where all the logic is. But what we do have in our model, so we've talked about, we have our pipe valve, we have our stream valve, and then we have our display. That's really the only three parts of this that are not just aesthetic, right? In our pipe valve, we have a click detector. Our stream valve has a click detector, and then the display just has a surface GUI and text label. So we just have that hooked up so that we can display the information back to us. So in our click detectors, so that allows us, whenever we click on one of these valves, it is going to trigger some code in our stream script that is going to make our GUIs visible. So I've already got the GUI set up. And I've got the pipe GUI, I've got the stream GUI, both of which exist within a frame. So the main thing inside the screen GUI is going to be a frame. And so having everything within a frame makes it really easy to flip it between being visible or not visible. So I can actually show that real quick. If we turn this on, so we can see we have our buttons here, we have our text label, and then whenever we click on one of these buttons, it's going to trigger some code within this GUI script. So this is a local script. The script only runs on the player, which is always going to be the case with GUIs. GUIs always run on the client side, right? They only exist on the player. And so these are both the same. We have a pipe GUI, we have a stream GUI. They both work exactly the same way. And what we're going to do first is we're going to cache these flow buttons, which are, of course, these flow buttons, these concentration buttons, these controller inputs. We're going to cache these to local variables. And then we need to cache basically go and get the replicated storage. So that's over here, replicated storage. And in our replicated storage, we have both of our remote events. And the remote events are how you connect what's going on locally with what's going on with the server. So whenever we click a button, it's going to fire a remote event that's going to tell the server do something. So that's how we connect those two things together. It's kind of like, front end and back end. If you do web development, it kind of works in the same sense, because we do have, Roblox runs in a very similar way, where we have local clients and the server working together. So we get our replicated storage, and then within replicated storage, we get our managed pipe flow, which is our managed pipe flow remote event, and we cache that to a local variable. And then for every button, we have this activated event. So anytime you click one of the buttons, it's going to trigger activated, and it's going to connect it to one of our functions that we write. And it's just going to trigger the event associated with each button. Actually, it's going to trigger manage pipe flow every single time, but it's going to pass in the button that we clicked, because that's going to be read when we connect it back to the stream script. It's going to look at which button got clicked so it knows what to do. And so that's pipe GUI. Stream GUI works exactly the same way. Actually, I want to go ahead and turn visibility back off so that's not going to be in our way all the time. And that's it for our GUIs and, for the most part, our replicated storage. Now we can start talking about our stream script and really get into the main part of this discussion. So we are going to set up our parent script, or our parent to the script. Call that stream. We have a local. We need these vowels because that's what we're going to be clicking on. And so that's going to be a child of the stream. And we have one for each, right? We have one controlling the stream, one controlling the pipe. And then we have our display that we'll be displaying our information back to. And we want to get the surface GUI and the text label. Now we need to connect to replicated storage. Service. Yeah, I gotta be real careful with these string references. Now we need to connect those events. Because you do not want to get a typo on those. Okay, so we've just set up our server events, our replicated storage, or service events, our replicated storage, and our two remote events within that. So now let's start doing our variables. So we're going to need a variable for pipe flow. And I like to just put in a comment on what these are. It's going to be liters per second. It doesn't have to be, but I think it makes sense to be liters per second. Or cubic feet per second, anything basically. Oops. Concentration there. We're going to start the pipe at 0. I mean, you can start it at whatever, but I'm just going to go ahead and start it at 0. But I'm actually going to start the stream with at least a little bit of flow. So we'll have 1 liter per second, and with 1 milligram per liter. Oh yeah, and then we need our mixed flow, or actually let's call it total flow, I think. And that's going to be, with our flow, it's always going to be the combination of the two flows, right? So we have our stream flow and our pipe flow, and because of the law of continuity, basically anytime these flows add together, you're obviously always going to have the combination of those two flows, right? You don't have mass leaving the system unless it's either evaporating or infiltrating, but we're going to assume that there's not any of that happening. And then the mixed concentration, oh yeah, let's call it total concentration. Now, we got to do a little bit more math here because we're going to do a weighted average. So we're going to have the pipe flow plus the pipe concentration. So basically we're looking at more or less the total mass, right? The flow, oh, not close. The flow times the concentration is going to be your total mass. And so if we add the mass together for both systems, concentration, then we will be able to divide that out and get what's essentially a weighted average based on the different flow rates, right? Because if you have like a very high concentration but a very low amount of flow, then it's not going to have as much of an impact on a stream that has a lot of flow, right? Because the total mass wouldn't be very much. Okay, so now we're pretty much set up. We can start writing some functions here. And so some of the things we need to do, we need to have some functions that are going to flip the displays on our GUIs, right? I guess we could start there. So we're going to need two of these. We're going to have one for display pipe GUI, and we need to know whose display, right? Because again, this happens on locally on the client, so we need to know whose client to affect. And we can do that because we can pass that information on for who clicks on something. With a click detector, you can pass in which player clicked, so we know which player it is. Player GUI. Okay. And so we're just going to basically flip the Boolean from whatever it is. So we can do that by saying it's going to be equal to not whatever it is. So if it's true, it's going to be false, and vice versa. Let me make this a little bit easier. Just copy paste. Okay. And we're going to need to do that again for the other display. That was pipe, need stream. I'm going to copy this. Always got to be very careful. This is the best way to make a mistake, or the easiest way to make a mistake. In fact, that was wrong. This should be pipe GUI. Okay. So now let's connect these from click events. So I like to do an event just to handle click events, which is maybe seems kind of silly, I don't know, but I do like to do that so that I can explicitly pass the player through. And it's going to, basically all it's going to do, it's going to get called and it's going to call the display pipe GUI function itself and pass in player. That's it. That's all it's going to do. And we're going to do another one for the other stream. Let's see, on-click stream valve. And we're going to call it display stream GUI and pass in player. All right, now we need to call those functions. So what we'll do is say the pipe valve, which is the local variable of the actual part, the pipe valve part. We're going to call that click detector on it. Detector, yep. And we're going to call the mouse click event and connect it to the on-click pipe valve function. And do another one for the stream valve. Oops. Yeah, I've got. Try to do that twice. Okay. Okay, hopefully there's no screw ups there. Looks all right. I think let's go ahead and I'm probably going to forget this later. I'm putting a note to myself to do server events. All right. So now we can start writing our actual functions. We're only going to have 3 of them. We're going to have one that's going to handle updating the pipe flow based on what button events get passed to it. We're going to have basically an identical function for the stream flow. And then both of those at the end are going to call a function that's going to update the total flow and update the display. All right, so let's go ahead and do the pipe flow. And we're going to pass in, actually not player, but we want to pass in the button. And so we're going to pass in player first by default, but then we're going to pass in the button, which is the button that got clicked, right? Because we want to know which button got clicked. And we're going to do this by basically kind of like a switch condition or case condition, but we're just going to do it with a series of if, else ifs. So if button text, so if the text of the button is, and of course you have to be very careful here that you don't have any typos, but if it's flow up, then we're going to increase the pipe flow. Else if, oops, is that not? Yeah, else if. Same thing. Is flow down, then we are just going to decrease the pipe flow. Now you have to be careful that if you have like a period there or something as an abbreviation, you have to include it or it's not going to be equal to it. Let's see, so we're going to add that. Okay, so that is almost the function, except we need to call the update the total flow, which doesn't exist yet. So let's maybe go ahead and write that one, and then we'll come back and do the other stream flow. Okay, so we're going to need another local function, update total flow. Doesn't need any parameters. And then we'll say the total flow is equal to the pipe flow plus the stream flow, which is what we already defined it as before. And then the total concentration, actually, it's going to be this. Okay. Now, that's really it as far as calculating what the flow is. So that was pretty simple, but we want to link this to the display too. So let's maybe put a line in there. Let's make another variable, a string variable for the string text. And actually, I think I want to do pipe text first. Not that it really matters, but say something like pipe flow equals, and now we want to format this because if we don't, we're going to have random number of floating point values once we start dividing for our total flow. So let's just make everything just one precision point, one decimal point. And then I'll do a new line and say pipe concentration is going to be equal to, once again, I'm going to put one precision point, and I believe that is all that we need there. Pipe flow, pipe concentration, yeah, looks pretty good. So now we need to actually format it though. And if we're going to format it, we need to save it to something. So we're just going to save it to itself. Basically, just kind of form the format and update it. And so we need to pass it the string, which is string text. And then we need to pass it the variables, which is going to be pipe flow and then pipe concentration. And that's kind of, I think, an easy way to add variables directly into strings. That way you don't have to concatenate a bunch of stuff together. Plus you can format it. So I think it works out pretty well. And so we need to do the same thing for stream text. And in this case, because it's going to be below the pipe text, I'm going to go ahead and do a new line right from the beginning, which we could have put it at the end here. I guess it doesn't really matter. But we're just going to do the same thing here. And that is it on that. But again, we're going to have to format it. Yeah, so we're going to save it back to itself. String.format, stream text, stream flow, stream concentration. More for total, let's just call it total text. line. Flow. Total concentration. That's it. Except for formatting. I don't know why I keep trying to capitalize that. Okay. And now I'm just going to put in I just want to put in something here to kind of break that up. Actually, I need to do a new line. And then, just put a bunch of equals in there. And now we're going to concatenate it all together and then give it to our display text. Type text, concatenate stream text, concatenate horizontal rule, concatenate with total text. Awesome. Okay, that is done. Go ahead and save in case something like explodes. And now we can come back here and do our other local function here. And that is almost the last thing we need to do. Update stream flow. This is going to be really almost identical to this one up above it. In fact, I really could, again, this is kind of a bad idea, but I'm going to do it anyway. Only because I know I'm almost completely certain everything else is going to be the same. Okay, so the other thing we need to do, last thing we need to do, is add in our server events. So it's just 2 more lines of code. We're going to call manage pipe flow on server event. So when it gets called, we're going to connect our update pipe flow and manage stream flow on server event. Connect update stream flow. Awesome. Okay, I do believe we are ready to run this. Oh no. Okay, well, we got a little problem. Is that supposed to be capitalized? Probably. pretty sure. I'm completely sure. It should have been capitalized. Oh, because it's here too. All right, sorry about that. Okay, here we go. So we've got our pipe flow we're able to increase. It has no concentration to it at the moment, so it's actually diluting our flow. Let's turn it down a little bit, and maybe at 2, and turn the concentration up a lot. And probably putting the units in here would have been a good idea. But at 10, with 1 liter per second and 1 milligram per liter, we have a total flow of 3, which of course you would expect. And we have a pretty high concentration because we're not diluting it very much at all until, hopefully this works, if we turn our stream flow up, you can see obviously it's diluting the concentration down. And usually this is kind of what you would see, right? A lot of flow in the stream, lower flow in the pipe, but at higher concentration. And we can bump our stream concentration up a little bit. And that's it. That's how it all works. So hopefully that was interesting to someone out there. And if you have any questions, or if you would like to see something in addition to this, please put it in the comments. I'm considering maybe doing a part 2 to this, where we'll actually do non-conservative pollutants that actually have decay. We're going to have to model stream flow velocity so that we can get distance, for a given distance, we would know what the time elapsed is, and with the decay rate, we could model decay over time and relate that to different distances, basically. So that might be coming up in the next episode. We'll have to see how this goes. But thank you very much for watching.